Alright, as you can see by the learning goal at the top of this video, the goal is that by the time we're finished, I want you to know what average rate of change is and how we can apply this to quadratic functions or really any function at all. So what we're going to start off with is what the definition. So when we talk about average rate of change, here's what we mean. If we're trying to describe, by looking at a graph, we're looking at a set of points that could make a graph. We're looking at an equation that could give us a bunch of points. We want to try to figure out over some interval, and by interval what I mean is a set of x values. So I could mean, for example, from x is equal to 1 to x is equal to 10. Or I could say from x is equal to -3 or x is equal to 7. That's what I mean by an interval. So I'm saying, let's take some little chunk of the graph from x equals something to x equals something, and we're going to figure out how much the graph is changing. Is it going up really quickly? Is it going up very slowly? Is it going down very quickly? Is it going down very slowly? Maybe it's just average. We're trying to figure that out. But we're trying to get some idea about how quickly the graph is changing and also in what direction it's changing. All right, so we're going to start off by giving you the fancy formula. So this is the formula that we use to calculate average rate of change. So we're saying on the top, you're going to subtract f of x and f of a. And on the bottom, you're going to subtract x and a. And you might be wondering, well, what are x and a? What are f of x and f of a? And I'm explaining right down here. It says for some interval that starts at x, and then f of x represents the output for where we started. And it's going to end at some value a, just a variable to represent where the interval ends. And it's going to, the f of a is going to be the output from a in that function. And so this will make a lot more sense as we do a problem. It's actually very straightforward. But before we do that, I want to show you something that you've already seen before in Algebra 1 that is actually a type of rate of change, and that is the slope function. So if you notice, the slope function is really the same thing as my rate of change function. It's subtracting two inputs on the bottom, and it's subtracting the outputs that go with them on the top. So we're kind of really just calculating slope, but we're doing it for a curve, so we don't call it slope. It's actually more generally called rate of change. So we're going to look at a problem on a graph, and we're going to actually calculate a rate of change. Okay? So if you take a look at this graph, I'm asking for you to graph the average rate of change over the interval from -3 all the way up to +2. So if I was looking at the actual graph here, what I'm kind of saying is, let's start out here. Let's check out all the graph that goes all the way up to +2. And so it's kind of in this space here. I'm kind of saying, let's go from 3, okay, up to 2, or no, sorry, from -3 up to +2. And I'm just looking at this little chunk of the graph, and I'm trying to figure out right around like how quickly is the graph changing. And so the way we do that is we're just going to take the x values, which is -3, okay? And the formula said, if I take the beginning of the interval, that's -3, and I subtract the end of the interval, which is 2, that would be the bottom of my rate of change. The top is going to be what is the output, or what is the y value of -3. So if I go to -3 and I go up, I see that there's a point here, -3, 4. Okay? And so I'm going to say the output that goes with -3 that I'm going to write up here is 4. And I can do the same thing here. I'm going to say if I go over to 2, which is the second, that's the end of the interval, I'm going to say from 2, if I go up to the graph, again, I'm actually seeing this one also is at 2, 4. And so the output of this one would also be 4. So if I simplify this fraction, I'm going to say, well, 4 minus 4 is equal to 0. -3 minus 2 is equal to -5. And so in this case, when I simplify this fraction, I'm going to say the average rate of change is 0. And that actually makes sense, because I'm saying over the interval, approximately how much has it changed? And you can see at the beginning it was at 4. It kind of goes down and goes up, and then at the end we're back at 4. So it didn't change at all. I ended pretty much exactly where I started. And that's what we're trying to figure out. We're trying to get a number sense of what's happening. Okay? So just as a side note, I have this other notation here. It's got a square bracket and it has a -3, 2. Don't confuse this with a point. This is not like the point 3, 2 or -3, 2. This notation actually means start at -3 and go up to +2. So it's really another way of writing what you already see. It's another way of writing what was right above it. So you're going to see these used interchangeably. This is called inequality notation, the first one, and the one below it with the brackets is called interval notation. So you'll use those interchangeably. So here's an example for you to try. You can pause the video, make sure that you can calculate the average rate of change, and then I'm just going to work it out when you're ready to go. Okay, so if you've paused the video, you've had a chance to try it out, we're going to calculate the average rate of change. And I'm going to do this one. And what actually ends up happening in this case is I'm going to subtract the 0 minus 2 on the bottom. And then I'm going to say, okay, at 0, it looks like my graph, the output is at 2. Okay, and at 2, my output is again also at 2. So this is another case where it's actually 0 over negative 2, which is 0. So again, graph didn't change. I started at 2, I ended at 2. So let me show you an example where maybe something will change. So I'm going to put a 3 in here and say, let's check now the interval from 0 to 3. So the bottom is going to be, for the 0 to 3 interval, 0 minus 3. The top is still, I'm going to say, it's at 0, the output's 2, so 2. And then at 3, it looks like I have to go down to negative 1, right? That's 3 negative 1, so I'm going to say 2 minus negative 1. So let me just issue you a word of caution here. If you do 2 minus 1, you're going to get a wrong answer. Don't forget that you're subtracting, and there's a negative 1. So this is actually 2 minus negative 1, which is positive 3 over negative 3. So this one would come out to be negative 1, okay? And that would be my approximate rate of change. Okay, so it could be any number, fractions, negatives, positives, right? And you get the kind of the idea of how we're calculating. And so every other problem that I show you, so for example, this next one, is asking you to do the same thing, and I'm just presenting the information a little differently to you. So in this problem here, I'm asking you to calculate the average rate of change, but instead of giving you the graph, I'm giving you just the points in a table. So the idea is still going to be the same. I'm going to say, okay, the bottom of the fraction is going to be the x's, where I'm starting and where I'm ending. So negative 1 minus 10. And when I go to the table, I'm going to find the y values that go with negative 1. Well, negative 1 has an f of x, or an output value of 5. And then 10 has an output value of 4. So I'm going to say in this case, well, 5 minus 4 on top is 1 over negative 11. And so I'm going to say the rate of change, the average rate of change for this interval is negative 1/11th, or 1 over negative 11, any equivalent fraction to that. Right? And so we're kind of saying, and here's what this means, if we leave it as 1 over negative 11, I'm saying every single time we decrease x by 11, y is going to increase by 1. Right? So they're kind of going opposite from each other, but very, very slightly. It's a very small change. Okay? So the second problem is kind of asking me to do the same thing, except now they're asking me to compare two different intervals. So the second one is saying, if I compare f of x, which is the table, right? The table represents f of x, with some other function called g of x, which one's rate of change is higher over the same interval? So let's start off with f of x. If I go to f of x, okay, and say f of x is rate of change between negative 2 and 6, I would say, same idea. Go from negative 2 to 6, so negative 2 minus 6. The output at negative 2 for the f of x function is 2. The output for f of x for 6 is 8. So this one's rate of change, f of x's rate of change, on this interval is negative 6 over negative 8, which is simplifies to actually positive 3 over 4. So I'd say this is the rate of change of f. And then I can do the same thing with g. So I'm going to say g of x, its rate of change is going to go from, on the bottom, still negative 2 to 6, because I'm actually comparing them over the same x value, so the bottom shouldn't change. The top, however, because I have a different function, is going to change. So I actually need to figure out what is the output when I plug in negative 2. So I'm going to go up here and I'm going to find out. I'm going to say when I plug in a negative 2, this looks like negative 2 squared, which is 4. When I plug in a negative 2 to the middle term, it's negative 3 times negative 2, which is positive 6. And when I plug in a negative, I'm sorry, I don't have to plug in any more negative 2s, just plus 2. So that looks like 4 plus 6 plus 2, which is 12. Okay? And then I'm going to do the same thing with with positive 6. So I'm going to plug in a positive 6 to find out what comes out for that. I'm going to say, okay, plug in positive 6. That is 36 when I square it, minus, well, 6 times 3 is 18, plus 2. Well, 36 minus 18 is 18. 18 plus 2 is 20. So I said when I plug in a 6, I got back a 20. So when I simplify this, it looks like negative 8 over negative 8, which is 1. Okay? So if I ask you which one has the higher average rate of change, in this case, I'm going to say the one on the bottom. G of x's rate of change is 1, and that is bigger than 3/4. Okay? So let me make one more little side note, and then we have one more problem, and we are finished. Okay? So in in this problem, let's say, for example, that this one this negative 1, I'm sorry, this 1 happened to be a negative 1, right? Let's say that's how it worked out. In this case, we saw that it was 1. Let's say it was negative 1. If I were to do this, I would still say that g of x's rate of change was higher, even though technically negative 1 is smaller than 3/4 as a value. Because what we're actually going to do is we're just going to look at the number. We're going to say 1 is bigger than 3/4, but the negative is telling me that the 1 is a bigger change, but it's decreasing instead of increasing. So when you're comparing your two rate of changes, don't look at the sign. The sign's going to tell you whether it's going up or down, but we don't really need to think about that when we're actually thinking about the value. So I'm still going to say, even if that said negative 1, that 1 is bigger than 3/4, so g of x's rate of change is more. Okay. So again, here's a problem for you to try. I'm not going to do this one in the video because it's very similar to the last problem that we did. And I'm going to move on to the last problem. And we're going to compare this one. So just so you can see one more problem with rate of change, what we're going to do is we're going to say 3x squared minus 2 and g of x is 2x squared minus 3x plus 1. And again, I'm asking you which one has the greater, and I'm using this new phrase, absolute value rate of change, which again is kind of getting at that idea that if I take the absolute value, I don't really actually care about the negatives. I'm just going to compare the numbers. Okay, so I'm going to do the same thing. I'm going to say for f of x, this is going to be almost the exact same thing as the last problem. For f of x, the interval goes from 0 to 10, so I'm going to do 0 minus 10. That's the x value change. And the y's are going to be, when I plug a 0 into f of x, it looks like I'm going to get 0 minus 2, which is negative 2. So I just plugged the 0 in, I simplified it, subtracted 2. Okay, and then I'm going to do the same thing for 10. When I plug in a 10, I'm going to get 10 squared, which is 100, times 3, which is 300. 300 minus 2 is 298. Okay, so when I simplify this, I'm going to get negative 300 over negative 10, and that's going to be a value of negative 30. So what I actually care about as the rate of change is not negative 30, but the absolute value of negative 30, which is why I'm calling it the absolute value rate of change. So I'm just saying it's changing by approximately an average of 30. Okay, the negative that we got out of the problem is telling me that it's a decrease, but I'm saying the rate of change is 30. Okay, so let's do that for g of x. So I'm going to say g of x, same idea. I'm going to plug in, and I'm going to say 0 minus 10 on the bottom because that doesn't change. Okay, I'm going to plug in the negative 2, I'm sorry, the 0 into the function. When I plug in a 0 here and here, these both cancel, and I just get the 1. Okay, when I plug in the 10, it's going to look like 10 squared, which is 100, so this becomes negative 200, minus 30 plus 1. So that's negative 230 plus 1, which is negative 229. Okay, again, when I subtract these, I'm going to get 1 minus 229. I'm sorry, that's negative 229. I knew I was looking for something. Okay, negative 229. So that's going to be a positive 230 over a negative 10, which this is going to be negative 23. Okay, so again, I'm going to take the absolute value of this because I just care about the number itself, not the sign. So I'm going to say in this case, it looks like f of x wins. That has the greater absolute value rate of change. It's changing by about 30 y values for every x value. And in the g of x, I'm actually saying it's only changing by 23 y values for every x value. So it's got a greater rate of change. Okay, so every single one of these problems use the exact same formula. It's just how you got your points. When I show you a graph, you pull the points off the graph. If I show you a table, you pull the points out of a table. If I give you an equation, you're going to take the equation, plug in the values, and make your own points. Okay, and so that's rate of change.